Good day and welcome to Medley School's tutorials. Today we are looking at oxidation reduction reaction, or you call it oxidation redox reaction. Objectives. At the end of the lesson, the student should be able to define oxidation, oxidizing agent, reducing agent, oxidation number, and also solve some of the examples that are associated with what? With oxidation reduction reaction. Oxidation is a process involving loss of electrons, while reduction is a process involving a gain of electrons. An oxidizing agent is a substance which accepts what? Which accepts electron, while a reducing agent is a substance which donates electron. So an example now of a reducing agent can be when we have potassium. Potassium is a metal, and if we write the atomic structure, we draw the atomic structure of potassium, you see potassium is 1, this is the nucleus, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Then we have another one, 11, 12, 13, 14, 15, 16, 17, and 18. Then we have another one as what? 1 here now. You have what? You have 19. So now when you look at this now, you see that, let's say that this is atomic structure of what? Of a potassium. Now, what with potassium, this electron here, what with potassium we do here is to do what? Is to take away, to give out this electron. And once you give out this electron, it becomes what? Stable. This shell here, we do what? We go. And once you give out this one, it becomes what? Stable. Because you see that the outermost shell here now is filled up. And with this now, it is not stable. But once you give out that one electron, it becomes what? It becomes stable. So in that case, it can donate what? It can donate electron to become what? To become what? A reducing agent. While that of oxygen, oxygen now does what? What's the atomic number of oxygen? Oxygen is what? Is 8. Now when you have it, this is the nucleus, you have 1, 2, you have 3, 4, 5, 6, 7, and what? 8. So when you look at this outermost shell, you see that here now, oxygen needs what? Needs 1, 2 electron to become what? To become what? Filled, or to become what? Stable. So because oxygen does not have what? 2 electrons to become stable, oxygen will go what? Will go out to do what? To borrow 2 electrons. And once it borrows 2 electrons, it becomes what? It becomes what? It becomes an oxidizing what? Agent. So that's why we say that oxidation is a process involving a loss of electron, while reduction is a process of what? Involving gain of what? Electron. So an oxidizing agent is a substance which what? Which accepts. So you have seen that oxygen are what? Accepted what? 2 electrons to become what? To become what? Oxidized. So in that case, we say that this is an example what? Of an oxidizing agent. While a reducing agent is a substance which donates electrons. So in that case, you see that potassium has given out 1 electron to become what? Reduced and become what? Stable. So in that case, you say that it is what? It is a reducing agent. Now we move to oxidation number. We say that oxidation number of an element in any particular molecular or ion is defined as the electrical charge it appears to have, as determined by what? By a set of arbitrary rules. These rules make it possible to calculate the oxidation number for the element in a reactant and product of what? Of a chemical change. So when you look at this now, you see that in this oxidation we have a stipulated rule we use to do what? Calculate the oxidation number. And now, whenever you have a valency, we say valency is the combining power of what? Of an element, and you add what? Charge on that what? Valency, automatically becomes what? Oxidation number. Now in chemistry, for us to know oxidation number of a particular element according to IUPAC, you say that, let's take for example, when we have oxidation number of oxygen. Let's take the oxidation number of oxygen. If I want to get the oxidation number of oxygen, I take the structure of oxygen This is the first chair, 1, 2, and the second one is what? 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. So we have 6 now. Then you have 7 and what? And 8. So now you see that oxygen needs what? Needs 2 electrons to become stable. So in that case, now it tells you now now oxygen has to what? Borrow 2 electrons. So it has a deficit of what? 2 electrons. So in that case now it becomes what? Minus what? 2. And this now gives you what? Gives you the oxidation number. This is the simple method of what? Getting the oxidation number of what? Of a particular what? Element. So in that case, this tells you that oxygen has what? Minus 2 electrons. But if I want to get that of potassium, this is potassium has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So you have 2, 4, 6, 8, 10, 12, 14, 16, 18. So you have another one here, 1 here, making it what? 19. All these things you have, these stars are what? Electrons. So you have a total number of 19 electrons. So in that case now, you see that all these shells are what? Filled up. In that case, when they are filled up, they become what? Stable. So the outermost shell here has what? 1 electron. And because that the energy required to borrow what? To borrow 7 electrons and make this outermost shell to be what? To be filled or to be in what we call octet structure is what? Is much than the one you require to do what? To give out 1 electron. So in that case, this man will do what? We quickly do what? Give out what? 1 electron. And once you give out this 1 electron, the last outermost what? Shell will be what? Will be what? Will be evolved. The outermost shell will evolve, or the thing will do what? Will vanish. And once it vanishes, you see that other shells become what? Becomes what? Stable. And once you give out this 1 electron, it becomes what? Stable. And in that case, now you say that it has what? Plus what? Because it's giving out, is in charge of what? That electron. So you say that it has what? Plus what? 1. So the oxidation number of this one is equal to what? Plus 1. While that of oxygen is what? Minus 2. So now, we have first example. It said, find the oxidation number of what? Manganese atom in potassium tetraoxo manganate what? 7. And we have KMnO4. That is what we call potassium tetraoxo manganate what? 7. So solution. For you to get this thing now, first and foremost, you take the oxidation number of what? Of the element. Now, the oxidation number of potassium, like I already said, is what? Plus 1. And the oxidation number of Mn, which is the one you are looking for, is X. Then the oxidation number of oxygen is what? Minus what? 2. Therefore, for you to get that, you now say, you take it, K is what? Plus 1 plus Mn is unknown, X. Plus what? The 4. Oxygen has 4 molecules. So you now say 4 what? 4 times what? Times minus 2, which is the oxidation what? Oxidation number of oxygen is equal to 0. Therefore, now you open the bracket, it becomes 1 plus X now. Now 4 times minus 2 will give you minus 8 is equal to what? 0. Then X now, sign, it crosses. X now will be equal to what? 8 what? 8 minus 1 will give you what? 7. And instead of writing 7, you say what? Plus 7, because we define oxidation number of an element in any particular molecular or ion is defined as what? Electrical charge. So there must be what? A charge. Not 7, but is what? Plus what? 7. If it is minus, we write minus what? 7. But the answer is what? Plus what? 7. 2. Find the oxidation number of chromium atom in potassium tetraoxo dichromate what? Dichromate 6. So you have K2Cl2O7, where the oxidation number of what? K is equal to what? Plus 1. I've told you how the plus 1 is gotten. And the oxidation number of Cl is equal to what? X. Then the oxidation number of oxygen is what? Is minus 2. I told you how I got my minus 2. So here now you have that the potassium you have now has 2 molecules of what? Potassium. Therefore, it becomes 2 now bracket plus 1, which is the oxidation number of what? Potassium, plus what? Plus 2, the chromium has what? 2 molecules. 2 now times unknown. That is unknown oxidation number, which is X, plus what? Plus oxygen has 7, plus that is 7 molecules of oxygen. You have 7 times minus 2 is what? Is oxidation what? Oxidation number of what? Oxygen is equal to 0. So now we have now 2 times 1, you have 2, plus what? 2 times X, you have 2X, minus what? 7 times minus 2, you have what? Minus 14 is equal to what? Is equal to 0. So therefore now, here now, we do what? You collect terms. You say that 14 now minus 2 will give you what? We give you plus 12. It becomes what? 2s is equal to what? Plus 12. Then you divide both sides by coefficient of what? Coefficient of x. Then what is coefficient of x? Coefficient of x is 2. So it becomes 2 now over 2 equal to plus 12 over what? Over 2. So 2 cancel itself. You have x. X will be equal to 2 cancel itself to 1 and 2 cancel 12 to 6. So x now will be equal to what? Plus 6. So this is the oxidation number of what? Of chromium in what? Potassium heptaoxide dichromate what? 6. And also plus 7 is the oxidation number of what? The oxidation number of manganese in what? Potassium tetraoxo manganate what? 7. So with this now, you must know the what? Oxidation number of a particular element before you can be able to do what? To do calculation that involves what? Oxidation number. So you must know what an oxidizing agent is. You must know what a reducing agent is. So like I already said before, I said oxidizing agent is a substance that accepts electron, while reducing agent is a substance that donates. So in your own term, you can use your own way to do what? To term an oxidizing agent and what? And reducing agent. You just link it. Use your own way to link oxidizing and reducing agent, so that whenever you do what? You come across oxidizing and reducing agent, you can be able to do what? To differentiate between oxidizing and reducing agent. Thank you for watching. See you in the next video.